Vibrating strings. An oscillator vibrates a string of length 2.1 meters with a fixed frequency, and it resonates in 6 loops. Here's the oscillator over here. The string linear density is 0.084 kilograms per meter, and the mass of the suspended block is 0.3 kilograms. What is the wavelength? What is the wave speed? What is the frequency of oscillations? And what will happen to the number of loops if the mass m of the suspended block is decreased? What is the wavelength? Use the wavelength equation for a vibrating fixed string, which is 2L over n. The length of the string is 2.1 meters. That's this length right here. And there are 6 loops. So we divide by 6, and we get the wavelength is 0.7 meters. What is the wave speed? We can try to use this equation, but we don't have the frequency. We just know that it's constant, it's fixed. So let's try the other equation, the square root of tension over mu, which is the mass density. We don't have the tension either, but using dynamics, we do a free body diagram for the mass. We have gravity pulling it down, the tension of the string pulling it up. Now the mass is not moving. So tension minus mg is equal to ma is equal to 0. There's no acceleration. So the tension is equal to mg. Substitute that in, and we can now multiply mass times g, divide it by mu, and we get a velocity of 5.92 meters per second. What is the frequency of oscillations? Well, we have our velocity is wavelength times frequency. We just calculated the velocity, and we know the wavelength. We calculated that too. So now what we have to do is isolate frequency by dividing both sides by lambda, plug in our value for velocity and the wavelength that we found, and we get the fixed frequency is 8.46 hertz. What will happen to the number of loops if the mass m of the suspended block is decreased? Well, now we have to use all our equations. We're going to set the two velocity equations equal to each other. So we have lambda f is equal to the square root of tension over mu. And what's lambda for this vibrating string? Well, it's 2L over n. And what's tension? It's mg. So we now have this expression here, this algebraic expression that we're going to analyze on the next slide. Now we're changing the mass, and let's circle that. That's over here. And we want to find out what happens to the number of loops. Well, they are inverses of each other. One is in the numerator and the other is in the denominator on opposite sides of the equation. So if you, for example, increase m, you would have to decrease n, so these equations would stay the same. So they're inverses. And then you're going to say, well, how about this frequency? Well, fortunately, that's fixed. The oscillator is putting out a constant frequency. So if we decrease the mass, all right, so let me erase this. I gave a different example there just to make a point. If we decrease the mass, the only way to make this side stay the same to still equal the right side would be what? Increase n. So the number of loops increases.